Good morning and welcome to planalvestech.com. Friends, life is a constant rummage. And here in Planalvestech, the rummage is necessary. Friends, in this video, we are going to talk about rummage and all the advantages it has. No, I am lying. In this video we are going to repair this rice cooker. A very common failure that these types of appliances have, and it is recurring in some appliances that have a type of electrical protection through a thermal fuse that what it does is protect the appliance from a possible short, or rather of a possible overheating, and thus avoid the risk of fires, etc. More than anything, it is a safety thermal fuse that many electrical appliances come with today currently. More than anything for the safety part, but I have noticed that lately they are failing a lot. They are calculating these thermal fuses that are being very close adjusted to the operating temperature of the appliance in question, in this case this rice cooker, that on despite of fact that it is almost new, or it is new really. And this failure has been also seen in irons and in blenders. Well, it could also happen that there has been an overvoltage or a fluctuation in the electrical net that has triggered off the thermal fuse. Can also be good. First, we are going to be sure to locate that the fault is due to the thermal fuse. First, we are going to rule out any other possible fault. As always, we start with the easiest by checking the power input cable. With the device disconnected, we will begin to check. The first thing we are going to check is the plug cable or power cable. Then on the lowest resistance scale, we begin to look here. Well, here we can see that a cable goes to what would be this thermal fuse, and the other cable goes here to this terminal. So we are going to verify that the cable is in good condition, right? We are going to verify continuity. It is showing continuity. Well, first we verify here continuity, that the tester is giving the correct measurement. That's fine. Well, we verify an input line from the power supply cable to the first pin of the plug, and it gives me continuity. Well, here then we quickly switch to the other side. And, well, logically we identify that the power cable goes through here. Right, it arrives through here and goes to this point and reaches this connection. And it does not give me continuity with this measure. With this test that we have done, it is already confirmed, or this reaffirms us that the fault is possibly in the plug or power connector, or else in the power cable. Well, here we identify that the power cable actually arrives here to this part, which is where this has a thermal cover. Inside this cover, there is a thermal fuse that is precisely about I was talking at the beginning of this video, referring to this dirty issue. Thermal fuse is very common. For it to trip off, what happens is that the circuit opens. This behavior is to protect from overvoltage, overload, or overload, no so much, but more than anything, from overheating event. Well, happens it opens, that is to opens the good circuit to protect, etc. And the device in question is dead without power, as we can see. Here, when we measure continuity between one of the pins of the plug and this terminal, we actually see that it does not give us. The tester does not show continuity. Well, then to finish, to be completely sure, we are going to move the cover a little bit and we are going to measure. Well, there already it's identified. The problem is that there is no continuity between one of the input lines. So we are going to remove this. Since I could not move this cover, so I am going to loosen this connector, this connection for a moment. Here we remove this cable and we leave it other part again in its place. Right now. Here is the problem. This is a 250 volt thermal fuse. Moreover, it tells me 20 ampere, 250 degrees Celsius. Obviously, this type of electrical appliances tend to heat up much more than that easily due mainly to the temperatures where it is placed. And of the site depends on where you are. Where you are using the appliance, it can rise a little more, a little less the temperature. So good, we are going to check this thermal fuse. Well, so here it is well glued. So well glued. They have put it well. Very well glued the thermal cover. Let's go to need cut. Then we are going to cut a piece of this. Here to be able to verify and know if thermal fuse is indeed open. Remember, do think twice that everything we do in electricity and electronics has to be checked and verified. We are going to measure between the terminals on the lowest resistance scale of multimeter, that in this case it is 200 ohms, and it is indeed open. The thermal fuse is open. This is the fault. So let's go. Well, we can also finish here, or to do a complete check, let's go here to check the another connection terminal with the plug. This connection here. And it has to give me continuity. Oh yeah, so that's it. The power cable is in good condition. The problem is this thermal fuse that we are going to remove. Really, this is not very necessary part. They do this more than anything to comply with a safety standard, to accomplish with stuff safety laws, etc. Well, so then what we are going to do now is cut here to get rid of it. Rather, we are going to bypass it and we are not going to put it again. We are not going to use this anymore. Because in my experience I have seen. What I have experienced is that when I replace it, it almost always comes back and fails, comes back and goes off. I have replaced it too, but as I told you, it fails. Every time I have tried to replace a thermal fuse with one higher temperature fuse, but they almost always come back, and these fuses trigger off. And the definitive solution is simply not to put it and connect the cable directly without the thermal fuse protection. Wow, yeah. Well then, here we are going to take advantage of this terminal. And the terminal ends here as in a fairly thick wire form. Its own terminal of the thermal fuse. That is all ready to discard. This same piece here, this same terminal, is the terminal to make our direct electrical connection. Here to the connection screw. Then we are going to remove this material, this protection here, and simply with the same, yes, with the same pin, which the thermal fuse is connected. We are going here to give to this wire a twist here, and it will be connected directly to its electrical heating resistor connection terminal. Well, this is how this cable looks. Cable section left to make the connection here to the same terminal where the thermal fuse went, which in this case we have suppressed. Then, well, we are going to connect this cable directly, but it is highly recommended that in this case is good idea this piece of thermal material like this thermal cover that it came with the fuse. And well, here came the thermal fuse, but as we have removed it, yes, it's good to keep this cover in this cable. Mainly that is placed here because the heat tends to be transmitted. Oh yeah, baby. And why? In this case it is important because the heat here in this terminal goes directly to the resistance end of the heat resistance, and it is connected here cause the heat in this cable is communicated to this part, and the heat will tend or will treat to spread along cable and may end up melting the insulation, which may eventually generate a short circuit in the future. Happen when it starts to heat up. And obviously the heat is going to spread along this cable and it is going to tend to melt around. Then in this case, the same piece of thermal cover is very important. Reposition it on this portion of cable mainly because it is connected here to this terminal on this heat resistance to prevent the heat from spreading through the cable and melting it and generating a short circuit here in this part. Good. We can do this. Well, we can here. This plastic can be removed here with we press it with a screwdriver. We apply pressure to this here and with the help of pliers like this, we force a little and it comes out here. What would be this plastic piece? This part that blocks here. For to stretch a little bit the cable. And that we can enter the whole sheath and we place it very well. This is placed again with a little of patience. A little patience. With a little help from the screwdriver, it plastic would enter. And yeah, we are going to exert pressure with the help of a little tweezers. We press and it enters. From the plastic part that what it does is presses the cable to maintain it in static position. And with its thermal cover, it is connected again. Well, as always, we are going to resort to, before carry out our test of operation, to our typical breaker or magnetic thermal protection. Very important when we are making electrical repairs. Use our breaker to protect both the installation of our house and the equipment that we are doing maintenance also. In this case, I have it with these two little alligators. Well, we connect here. Yeah, babe. We connect and ready. We have our rice cooker working again because we have replaced, or rather we have removed the thermal fuse that they bring for protection. But it really does not influence much. It does not influence at all in the electrical operation. Now continues to functioning normally without that thermal fuse. Okay, that's all, folks. That's all. Repaired the rice cooker. Typical thermal fuse failure in electrical appliances, and its solution is simply placing a higher temperature thermal fuse. Or just, we'll see that. If it fails a lot, then simply we suppressed the thermal fuse. That can sometimes be annoying due to this type of failure. Okay friends, that's all for this video. If this video has helped you, give me a like, subscribe to this YouTube channel to continue making more videos like this. Thanks for watching my videos and support my channel. And with God's help, see you soon in the next video. Bye. Oh yeah, babe. Members mentions Alvastech Space. Malay's Kepler, thanks for make part of members Alvastech Space. In description you will found the link.